Okay, so this is a conservation of momentum problem that is a bit more challenging because we've got a couple of collisions that are happening. So we've got a person who's throwing a particular mass snowball, so we're having a snowball fight, but the person is running at a particular speed. The snowball then has a speed when it leaves the thrower's hand, and then there is a person who catches it who's initially at rest. And we're trying to figure out what are the velocities, okay, of the two people after the snowball is exchanged, which is code for final velocity in this situation. So when in doubt, we want to draw it out and sort of basically visualize what we're trying to accomplish here. And there are two collisions that we're trying to keep track of, and we have to work them through different processes. Okay, so here are my two people. Here's our snowball. I've designated as red to help visualize where it is. We're looking at the final velocity of this guy and the final velocity of this guy. That's the ultimate goal of trying to solve this problem. Now, we've got an impulse that creates a change in the momentum of both the snowball and the thrower, and we have this situation in which we've got this guy who is going to have a change in momentum because of receiving the snowball. So we have to treat them as two separate things. But in both collisions, remember that the idea is that the total momentum before any collision, assuming that momentum is conserved, there's no external forces acting on it, it's going to be equal to the total momentum after. So that's a key thing that we need to keep in mind. Because the thrower, in this case, has a particular velocity, 2.50 meters per second, and the snowball is still in his hand, we can treat them as a combined entity. Okay, so the snowball plus this guy's mass times that velocity will give us their total momentum before the impulse happens to throw the object. Okay, so keep in mind that the snowball and the thrower are together. And then there's an impulse to separate them. So we're going to look at their combined momentum. So the initial, we'll just call this P1I, is equal to their combined masses times the initial velocity. Right, this is a little I there. That's 1I, 1I. So the initial momentum is a combination of 65 and 0.0450 times positive 2.50 meters per second. So this makes it a positive 162.6125 kilograms meters per second. Okay? We want to then try to figure out his velocity once he throws it. So now we need to look at after the throw. This is all before the throw. What is the momentum? Why do we do this? Because we need to know this number. If we know this number, we know that the after momentum is the same value. So now let's look at after the collision occurs or the impulse occurs. So we are going to look at after the throw and break it down. So if we look at just the thrower, because now they're going to be separated. So let's look at just the thrower. We have P1 final is equal to M1 V1 final. So we're trying to figure out this value. That is our ultimate goal. We know the mass of the thrower, right? So we know this information, but we don't quite know what the thrower's individual momentum is. Okay, so we don't have enough to use this yet. So let's see if we can continue to troubleshoot it. So let's look at the snowball, and I'm going to do the snowball in a different color here. So the snowball is also going to have momentum, and we can say that it is, we're going to say just P2F equals M2, because they have different individual momenta. So I'm labeling this as a 2, the snowball final, okay? And you can label it really however you want to, as long as you know how to keep up with it. So this we know that the snowball is thrown at this speed. Okay, we know that it's thrown at this speed. We know the mass of the snowball. So we have all the information to figure out the snowball's individual momentum. Remember that the total momentum of the system after should be this. This should be the total. But I need to break it down by the individual. So I've got 0.0450 kilograms times positive 30 meters per second. And that's going to give me the final momentum of the snowball is a positive 1.35 kilograms as meters per second. Okay? So, to go back and say our total after equals our total before, our total before is this. So we say total P, basically, final, equals P1 final plus P2 final, right? This final, the thrower, plus the snowball should be the total. So we know the total is a positive 162.6125. We're trying to find the final momentum of the thrower, and we know this momentum is positive 1.35. We subtract this out to the other side. So we have the final momentum of the thrower should be a positive, if I did my math right, 161.2625 kilograms per meter per second. That new information can now be used to solve that. So we take that information, positive 161.2625 is equal to the mass of the thrower, which is 65, times the velocity of the thrower. Divide 65 out. Divide 65 out. So you have V final of the thrower should be the division of that, which is a positive 2.48 meters per second. So we have solved part of it. We've only solved for the velocity of the initial thrower. Now, we can look at the receiver of the snowball. So, think in terms of before. So let's write down what we know, and I'll start it on a different sheet of paper, or put it like this. Okay, so let's look at this guy. So make it a little thicker there. So we have to examine the before the catch, which is the collision in this case, and we're going to look at after the catch. Okay, and whatever the momentum is before the catch should be the momentum of the system after the catch, but this and this will not necessarily have the same momenta, okay, because these are two different collisions actually. So we're looking at before the catch. So before the catch, we have the snowball. And we can look at its momentum. So we have P1 initial equals M1, or really just M1 V1 initial. So the snowball has a mass, and the mass was, or is, 0.0450 kilograms. And its velocity is this, coming into the person. So that gives it an initial momentum of a positive 1.35 kilograms times meter per second. Now, the catcher of the snowball, if you look at his momentum, M1 V2I, because he has no velocity, he actually has no momentum, so it's going to be 0. So the total momentum before the catch is just a positive 1.35 kilogram times meter per second. Now, after the catch, when we're looking at it, so we say the snowball and the catcher will have a combined momentum. So this is an inelastic collision in which the snowball is caught by the catcher. So they are going to move together. Okay, so this is an inelastic collision. So when we break that down, we're going to have our momentum before. It's the same as the momentum after. So our total P, let's get it all set up, is a positive 1.35 kilograms per meter per second. So the final is really M1 plus M2 times their combined velocity, which is really what we're looking for, because we're trying to figure out how fast this guy is moving, right? That's our ultimate goal, is to find his velocity. Now, his velocity is going to be determined by his mass and the snowball, and the snowball is fairly negligible. It's a really tiny mass, but we add it up anyway. So we have our momentum is equal to our masses, so we have 0.045 plus 60 times V. So this number is a positive 1.35. This is 60.0450 times V. Divide by 60.0450 kilograms. 60.0450 kilograms. And that's going to make the velocity, oops, went off the page. That's going to make the velocity very small, 0.02248 meters per second. And this is the velocity of the catcher in this situation. And it's going, the catcher is moving in the positive direction, right? The snowball comes in this direction, catches it, and he moves off in that same direction. And that's your second answer. And we are done.